So, hello everyone. My name is Xiao, and I'm a senior developer who has more than 10 years of experience. And I've been using the OpenAI API for the past 3 years. Started with GPT-3, and now they have GPT-4. I'm also a business owner who own a dev shop, and recently we're more into AI and LLM consulting. So before we get started, let me ask you guys a few questions. Raise your hand if you use ChatGPT at home. Okay, pretty much everybody here. So raise your hand if you already played with OpenAI's API. Okay, a bit less people. We're going to talk more about that today. So the reason why LLMs, which stands for large language models, became very popular recently is that it make AI way more accessible, right? There's no need, at least for the basic usage, there's no need for a massive training set to train the model because the model is pre-trained. Also, the price is very reasonable if you are using OpenAI, and it is available in all languages. If you are making an app that has to support multiple languages such as English, French, Spanish, Chinese, Japanese, Korean, then whatever language you need, the LLM is able to understand it. So let's get into the OpenAI's GPT models. There, like I said before, it is very affordable, accessible, because you don't need to have a supercomputer with a very powerful GPU to run the models. You simply need to make an API call. And it's very cheap to make those API calls. And it is still the most powerful model on the market. So if you haven't tried OpenAI's API, you can get the key from the link here. So LangChain, have any of you used LangChain before? Oh, very few, actually. So LangChain is a very popular Python wrapper for OpenAI LLMs and also other LLMs as well. They support a bunch of other LLMs. So it's also available in JavaScript, and it's open source. And but I would recommend using the Python version because it's one that got most updates. The reason you will use a library such as LangChain is because it has a lot of built-in feature already made for LLM applications, such as the LLM chains. And it saves you writing quite a few lines of code if you're using a library like that. So here is below I include the documentation on LangChain here. So the most basic way to interact with an LLM is through prompt engineering. If you guys already use ChatGPT at home, I assume you guys are familiar with that. You can ask a very simple prompt such as, explain what is the dev conference in 2 sentences. It does the job, but it's a bit wordy, but it does its job here. So there's 2 types of models for OpenAI. The first one is chat model. It's mainly been used for chat applications such as ChatGPT. And it's great for any application that is expecting to return wordy messages. However, there's a disadvantage of chat models. They are less deterministic. If you want it to return a particular output, such as HTML or LaTeX, or simply a yes or no answer, you may have trouble with it. So in this case, you need the completion models. which is great for answering true and false question. You can ask it for very specific output. So answer only true and false for a given question. Why this is important? Because this is very useful for LLM chains, basically chaining the prompts. So you can use the output from one prompt as the input for another prompt. You can create an LLM chain. I'm not getting into too much detail in the LLM chain. You guys can check the documentation again. I can include the link to the LLM chain documentation from LangChain. So yeah, so how do you usually train? How do you usually train LLM? Well, usually since LLM models are pre-trained, they know how to do a normal task, such as I get my example here, writing an email. And the only thing it doesn't know is how to write a personalized email that fits your voice, your tone. To do that, you only need to provide a few examples. We call it few-shot learning, few-shot examples. So my example prompt here, you guys can read the slides over here, is, nice to meet you. I received a follow-up email from Kung Fu, and how do I write a reply, right? I can give a few examples of my past reply to the prompt, and you will generate a more personalized reply message for me. So what if I need to integrate more external data to the LLM, right? Because the LLM prompts has a limit usually in terms of token. So you cannot include like a PDF of you cannot include a 1,000-page PDF into the prompt. So yeah, so there's two ways of doing integrating external data source to the LLM. One is doing the fine-tuning, which is similar to traditional supervised machine learning. In this case, you would need to prepare a training set with well-labeled data to show to the model, and then you fine-tune with at least usually a few hundred examples to tune a better model than the base model. Another way of doing it is through what we call retrieval augmented generation. Basically, it's a search algorithm that you will look into your existing unstructured data, such as PDF. You try to find the relevant data, and you use those data to augment your prompt. So let's talk briefly about fine-tuning. So very similar to traditional supervised learning, but with the power of a pre-trained model. It is good it is great if you have a lot of example ready for the training. And if you tune the model, you would need less. You would have a shorter prompt for future input, because you don't need to have few-shot example anymore into your prompts. However, the main challenge with fine-tuning, from my experience, is very time-consuming to gather the data to prepare the training set, and you require large amount of examples to be effective. Otherwise, you just do few-shot learning, as we see before. And if you are using real data from your user, it can be dangerous because you may run into privacy concerns. If you are training with the data of user A, you may not guarantee the LLM to not outputting the private information from user A to user B. So you may run into privacy issue in this case. And that is why the second method is better. I would recommend to use retrieval augmented generation to extend LLM's knowledge. And how do we exactly do that? Let's refer that as RAG from now on. So how RAG work is you will augment your prompt with external data source. And this data source doesn't need to be structured. It can be your internal documentation that you use for employee onboarding, or it can be just raw data from a web page. So, and it works well with other LLMs as well. So if you have a RAG pipeline ready for OpenAI's GPT, you can easily use the same code with another model such as Llama 2. So how does it work exactly? So the way it works is you will turn your data into vector embeddings, which are mathematical representation of the text data. So you can use OpenAI's ADA model to generate those embeddings. So you do it by first turning an unstructured data source into embeddings, and then turns the user query into another vector embeddings. Then you perform the RAG pipeline, the basic RAG pipeline. So the idea behind that is you have to find the closest distance between the two vectors. You have to find the vectors that has the closest distance to your query's vector. So here we have an illustration about the RAG pipeline. We just talk about point 1 to point 3 over here. We'll go over the rest later on. So for the search algorithm itself, you can use OpenAI's search API to do the embedding search, the embedding matching. So in your real application, you would also need to store the vector embedding into a vector database, because you will save time and also resource. So you don't need to call the embedding API every time in real time, every time you have a query. So if you are already using a classic traditional database such as PostgreSQL or Redis, they have plugins for vector search. And for new application, you may try some dedicated vector database which are made for vector search. The advantage of using those databases is that they have some extra cherry on top of cake features, such as built-in integration with either LangChain or Llama Index, which is a competitor of LangChain. So yeah, so example of those databases are PyCon and Chroma. So now you get matched embeddings from your data set. What do? You can convert it back into text data and then feed it into your prompt. Then thus enhance your prompt with the data source knowledge. Right. So yeah, again, I include the illustration here. So to better illustrate how it works, I'm giving you an example of an app that I made called Mail Magic. So Mail Magic use RAG techniques to generate draft reply for emails that come into my inbox. So if you can generate replies while I'm sleeping without me typing any prompt. And how does it work? So you read your past email and turn them into vector embeddings. And whenever you have an incoming email, we call it the queries. We also turn that into vector embedding. So we run a search algorithm to extract the matching vector from your knowledge base, which is your inbox. And then we generate an enhanced prompt with the incoming message and also the past email that looks similar to the message as few shot examples. And then we give the final prompt to the LLM. It can be GPT or Llama. So let's take a closer look at how the matching work. So the idea of the matching is, for example, after this conference, some of you may send me a message asking me a question or a service. I hope you guys send me a message like that. So yeah, so if you send me a message like that, what my RAG pipeline is doing is I'm going to look into my send inbox over here. Can you guys see the message clearly? So yeah, so this is the incoming. On the left is the incoming message. On the right is one of the past message that is a match. Why is matching? Because in my sent inbox, you always have the original message in quote below here. So you see there's a big similarity between these two messages. One is asking a follow-up after Kung Fu. Another one is asking a follow-up after the Web Summit. So that's why it's a very close match. And what and once I get this message, I can look at how did I reply. How did I reply to this message, which is on top of the image on the right. So yeah, so you see here, it says, great meeting you at the summit. I'm doing AI consulting now. Let's discuss in detail next week. So now I can fetch this exact message and use it in my prompt as a few shot example. So this is my final prompt over here. So I include in my prompt, it was great meeting you at Kung Fu. Can you tell me more about your service? And I asked you to write a reply to this message. And here are some of my previous example. And these are the few shot example generated by the RAG pipeline. So yeah, there's a lot of other applications that you can use using the RAG technique, such as chat with a PDF. You know, is there anyone tired of using Control F all the time? Yeah, so here we go. You can program a smart search algorithm that finds you information in a large PDF. So that's an example of application you can program with. So also you can generate you can program a bot for your FAQ page. If you have an e-commerce store, people is never going to read your FAQ, right? So it's easier to program a bot that use the FAQ as a data source and answer to the customer's question. That's similar with customer service bot as well, and also personal AI assistant. And if you have a product catalog that you are going to sell to people through an e-commerce store or a marketplace, you can also implement a product recommender system and use your product catalog as the data source. So here I included more resources on OpenAI and LangChain, and also a tutorial on more advanced RAG technique offered by deeplearning.ai. This tutorial is free, and for a limited time, they say. So just please take a look immediately after the session, after the conference. And yes, thank you for coming. Any questions?